Hello everyone and welcome to this session. Today I would like to show you how to choose the right database for your use case. Okay, I like to think of databases like restaurants. Okay, if you're trying to get married, you probably need to order catering, and if you're hungry on your way to work, you probably need some fast food. And that's how databases are engineered as well. So you need to have a great understanding of the database to figure out what's going to work best for your use case. Sometimes you need a combination of different databases to handle different operations within your setup. So just first of all, or you might need to hone in on just one, but you need to understand what each database does, and that's what this session is here for. Okay, so I'm going to use like restaurant analogies, like I did from the beginning, to explain what each of these databases does efficiently, so you can use that knowledge when you're trying to choose the right database. We're going to go ahead and jump right to it. Number one on the list is DynamoDB. Okay. In terms of restaurants, I would say DynamoDB is fast food. Okay. When you think of fast food, what do you think about, right? It's like orders are processing under, in a short period of time. Simple menu. It can handle massive crowds, and yeah, no reservation is needed, right? And how that would translate on a technical front is, you know, sub 10 millisecond response times, things like simple key data structure, auto scales to millions of requests, no capacity planning required. And you see, that rhymes so well, or translates so well to a fast food restaurant, right? So the best time to use DynamoDB is when you need lightning fast responses. Okay. When you need, when you have like massive and unpredictable traffic, which is same as fast food restaurants, and simple data queries, like just like simple menus, right? Nothing complex. It also gives you the ability to scale on a global level. Okay. And if I were to give you examples, real life examples of where DynamoDB would be good, think about like mobile game leaderboards. See, millions of people are updating scores on these leaderboards. Um, and then traffic spikes are unpredictable, you know. Another good example would be shopping carts for e-commerce. The reason for that is because you have like thousands of devices sending data. They need to store millions of readings and simple time series data as well, right? Or if you want a third example, which is very relatable, like social media user sessions. Okay. It tracks what users are doing, millions of concurrent users, fast login, fast logout operations, and things of that nature. So DynamoDB will be great for those. Okay. But if you want to go into like standard RDS, which is our second type of database under this, I look at standard RDS in terms of restaurants. I would consider it a traditional sit-down restaurant. Okay, it's like a local family restaurant, structured service, complex menu, handles relationships well. Because the key characteristics of a standard restaurant would be like waiters take complex orders, kitchen coordinates multiple dishes, reservations, table management, and how that translates to a technical, in like a technical way, would be like complex SQL queries, structure relationships between tables, um, ACID transactions. Like by ACID transactions, I mean like inventory, money transactions, things of that nature. It will also require existing SQL knowledge, and then it will handle scaling, but moderate scaling, right? If you like real world scenarios for this would be like maybe small business CRM, okay, which can handle maybe like 1,000 to 10,000 users. And obviously in this databases, like the tables will have complex, customer to other product relationships. Then reliable transaction processing. And then also, probably budget conscious, it's a small business, so friendly budget. Now, another good example would be like inventory management systems. Okay. Think about like tracking products, supplies, warehouses, need accurate stock counts, complex reporting requirements, and established business processes, things like that. Or even another good example would be like an HR management system. Okay. Keeping employee records, complex reporting with salaries and things of that nature. Also keeping track of compliance and audit requirements and things of that nature, right? So the third type of database on the list, Aurora, which is basically just an advanced RDS, right? A more robust RDS, but with a better engine. Think about this like a high-end restaurant chain, okay? Again, the restaurant analogy, high-end restaurant chain. With all quality of fine dining, multiple locations, backup systems, and things of that nature, right? So what I would consider characteristics of such a restaurant would be like multiple kitchens and chefs, multiple kitchens plus chefs, premium service, can serve multiple locations at once, and if one location has an issue, we can always make up for it, right? So how that translates to a technical, like from a technical perspective, as far as like the use case would be, first of all, Aurora has 6 copies of data across 3 availability zones. So there is very robust architecture there. It also supports automatic failover within 30 seconds. Within 30 seconds. Up to 15 read replicas to support high read transactions, right? Or high resource intensive transactions. It also has 3 times the performance of the standard RDS. Okay. It has high availability inbuilt already. Okay, doesn't have to be configured, already inbuilt high availability. Like we mentioned with the 15 read replicas, it does handle a lot of read workloads. Okay, so a good example of scenarios where an Aurora instance will be required would be like maybe financial trading platform. Okay, where there's like zero tolerance for data loss, like no data loss whatsoever. um, Sub-minute failover, and so many like regulatory compliance requirements. Another good example for this would be a good healthcare management system. Okay, because in healthcare, we know that patient records, there's zero tolerance for losing patient records. You know, you can't afford any kind of downtime. Um, and then you also have to meet strict compliance and audit, and then also multiple hospital locations for the franchise hospitals, right? So that would be a good use case for Aurora. Finally on the list, we have Redshift. Okay, so Redshift is very specialized. Okay, I would think of Redshift as a catering company. Okay, so if I wanted to have two extremes here, it would be um, Redshift and and DynamoDB. So DynamoDB and Redshift will be the two extremes. Okay, so Redshift, think of Redshift like a catering company. What when you think of catering, what do you think about, right? It's like very huge. They handle very huge volumes efficiently, right? Because if you're ordering catering, you want them to take care of like a wedding, things like that. You have to plan and prepare in advance. A lot of planning and preparation, right? Um, Specialized equipment, very specialized, you know. And yeah, that's what catering would entail. And if you wanted to, what's the technical equivalent of this? So I'll think of like very optimized, um, very optimized and like targeted queries, right? Large scale queries for analytical data, uh, fast aggregations for columnar storage, processing data in quantums like terabytes, you know. Um, so Redshift would be good for like analytical data sets, business intelligence, BI, data warehousing, and like historical data analysis. Okay, so like a real scenario for Redshift would be like retail chain analytics. Think about like a Target or a Walmart, trying to figure out what happened to sales in the last 25 years, you know, um, over 1,000 stores in specific geographical areas, things like that. Calculating return on investment, or forecasting future quarter sales based on data from the last 24, 25 years, things like that. Or think about maybe like marketing campaign analysis, trying to figure out return on investment. Or another good example would be like health research. Maybe there was like some kind of medication that was used and they want to see how analysis of how patients reacted to it over time, over 20 years of usage of their medication, things like that. What happens if you add this or take this out, things like that. So all those kind of clinical trials, population health studies, medical research analytics, and things of that nature, right? So that would be Redshift. Now, like I said, I don't know if I mentioned this at the beginning, but sometimes it's not an all one size fits all kind of mentality. Sometimes you need to incorporate different databases in different work environments. I already spoke about, the retail store has to keep track of, um, you know, orders. They have to do analytics. They have to do a few things, and sometimes a specific database is not gonna fit all your use cases. Sometimes you may need to use a combination of both, right? A combination of a few databases, right? A good example, I'll use maybe social media, for instance. You know, in social media, I think that DynamoDB will be good to handle like posts, likes, and like real-time feeds based on what we have discussed earlier. And then maybe Aurora will be good for like user profiles, friend relationships, and Redshift will be good for like user engagement, analysis over time, right? Things like that. This will help them create better features and things like that, right? And then if you maybe company was like a gaming platform, DynamoDB will be excellent for like player stats and like leaderboards, while traditional RDS will be good for like user accounts and like payments. And Redshift will be like good for like player behavior analysis. Yeah, so you see, like the key is about choosing the right database for the right use case. Again, sometimes one company can require multiple versions, multiple types of databases, and sometimes it may not. So depending on your use case, choose the right database, and everything should be great. Thanks.